Hello students, today I am going to discuss about other reaction of aryl halide. First reaction is Fittig reaction. This is not fitting reaction. By mistake in syllabus there are written fitting, but truly name is Fittig reaction. When aryl halide react with sodium metal in presence of dry ether, diphenyl is obtained. This reaction is also known as Fittig reaction. In other words, aryl halides also give analogs compounds when treated with sodium in dry ether, in which two aryl groups are joined together. It is called Fittig reaction. Here example of Fittig reaction: chlorobenzene, 2 mole of chlorobenzene when react with in presence of sodium metal. So this sodium react with this Cl to form sodium chloride, here removal, and this both phenyl ring are attached, this and this carbon, to form biphenyl or diphenyl derivative or compound. Thus a simple any aryl halides when react with sodium in presence of dry ether, we can get easily diphenyl derivative compound. Now second reaction is Wurtz-Fittig reaction. A mixture of alkyl halide and aryl halide give an alkyl arene when treated with sodium in dry ether and is called Wurtz-Fittig reaction. Other words, formation of alkylated aromatic hydrocarbons on coupling of an alkyl halide and an aryl halide in presence of sodium. In other words, when aryl halides are heated with alkyl halide in the presence of sodium metal in anhydrous ether, halogen atom is replaced by alkyl group. This reaction is also known as Wurtz-Fittig reaction. For example, chlorobenzene react with methyl chloride in presence of sodium metal gives toluenes. These are the example of Wurtz-Fittig reaction. This is general method of this is halobenzene, where X means halogen, Cl, Bri. This halobenzene when react with alkyl halide with sodium metal in presence of dry ether, here minus NaX byproducts, and we get here X is converted to here alkyl group. So here alkyl benzene is formed. The resultant product is alkyl benzene. So Wurtz-Fittig reactions, we get halogen is converted into alkyl group. So halobenzene is converted into alkyl benzene. In second example here halobenzene, so here chlorobenzene is taken here. Chlorobenzene when react with methyl chloride in presence of sodium with dry ether to form toluene. So this is general example, and it's example of how to toluene form by chlorobenzene, or how chlorobenzene is converted into toluene via Wurtz-Fittig reaction. Another example here we taken bromobenzene in the presence of ethyl bromide. Ethyl lesson here converted. So ethyl bromide and sodium in presence of diethyl, this bromobenzene is converted into ethyl benzene. So here halide is converted to this alkyl group. So above reaction is known as Wurtz-Fittig reaction, and it is used for preparation of alkyl benzene. Alkyl means here R. R means methyl, ethyl, propyl. After completion of reaction, we are getting very poor yield of the product. So another example of this Wurtz-Fittig reaction here, when bromobenzene is react with normal propyl bromide in presence of sodium and dry ether. Here minus sodium bromide are byproduct and propyl benzenes are here formed. So how many carbons of alkyl we required? This type of alkyl bromide here taken. So bromobenzene when react with normal propyl bromide, so this propyl chain here attached to this carbon and propyl benzene is formed. Now third and last reaction of this chapter, Ullmann reaction or Ullmann coupling reaction. So what is Ullmann reaction? Synthesis of bi-aryls. Bi means two or di. Aryl means aromatic rings. So bi-aryls in presence of copper induce coupling of aryl halide is called Ullmann reaction. Now, iodobenzene is heated with copper powder, biphenyl is formed. For iodobenzene, when heated with copper powder in a sealed tube to form diphenyl. This reaction is known as Ullmann reaction. So here iodobenzene taken example, in presence of copper, 2 mole of iodobenzene with induce coupling of this copper, this cuprous iodide here removed and biphenyl or bi-aryl or diphenyl is formed. So this is simple reaction of Ullmann reaction, and resultant product is biphenyl. Another example of general halobenzene, 2 mole of halobenzene and it taken in the presence of copper powder when heated or above 20 degree temperature. So this halobenzene is converted into diphenyl, and here cuprous halide is byproduct generated. So another example of these 2-chloro-nitrobenzene. So when taken 2 mole of 2-chloro-nitrobenzene, same reactant here in the presence of copper powder when heated with temperature at 20 degree 200 degree Celsius. So this diphenyl or biphenyl derivatives are formed. So here 1 and 1 position or ortho dinitro biphenyl derivative is generated. So here also cuprous chloride or by-product is here generated. Now order of reactivity of aryl halide is reactivity here aryl iodide is greater than aryl bromide is greater than aryl chloride. So aromatic ring having electron withdrawing groups such as nitro group or carbomethoxy, this is ester group, at ortho position activate the ring towards coupling reaction. So here parabromo anisole plus 2 chloronitrobenzene when react with in the presence of copper powder, 195 degree temperature here taken. So here biphenyl derivative also converted, but this halogen it attached to this ortho position of 2-nitrochlorobenzene, and resultant product is 2-nitro-4-methoxy biphenyl. 2-nitro, here 2-nitro, 4-methoxy biphenyl, and CuCl or CuBr, cuprous chloride and bromide are byproduct. This is the simple mechanism of this biphenyl derivative, how forms. Here aryl halide plus copper, simple. Here aryl react with this copper, so copper complex, aryl copper complex here formed, and another aryl halide when react with, so this CuX is byproduct and aryl are here coupling. So this another example or application of this reactions. So when we taken peroiodo benzoic acid in the presence of copper and benzene, so 4 days biphenyl dicarboxylic acid derivative is generated, and cuprous iodide are byproduct here. So this is another example of biphenyl derivative. So these 2 mole of 2-bromopyridine in presence of copper with benzene. So this is the pyridine derivative. So 2 days bipyridine derivatives are formed, and cuprous bromide are byproduct. And last topic our this chapter is relative reactivity of alkyl, allyl and benzyl, vinyl and aryl halide towards nucleophilic substitution reaction. So is general form of alkyl halide here are CH2X, CH2 double bond CHX, it's called vinyl halide. This is simple aryl halide. This is the CH2 double bond CH2. So this is called allyl group. So this is allyl halides, and C6H5CH2. This is called benzyl. So this is benzylic halides. Vinyl halides and aryl halides are less reactive than alkyl halide. These are mainly due to aryl and vinyl halide have partially double bond character between carbon and halogen atom. As a result, CX bond of aryl and vinyl halide is stronger than that of alkyl halide. Thus, CX bond cleavage is more difficult. As shown below figure, the p orbital of chlorine, p orbital of chlorine atom having a lone pair of electrons overlaps with the unhybridized p orbital of carbon, is resulting partial double bond character to CX bond. As a result, halogen atom halide becomes tightly attached to a carbon atom and cannot be substituted. So this is the aryl halide chlorobenzene. So this halogen is tightly attached to this carbon. So sidewise overlapping is here possible because of here this halogen contain a lone pair of electron Also this vinyl chloride, this halogen which attached to this carbon, so sidewise overlapping here in aryl halide and vinyl halide is possible. So however, there is no possibility of double bond character in CX bond in alkyl halide or benzyl halide. Therefore, the filled p orbital of halogen atom cannot over sidewise overlapping with the unhybridized p orbital of carbon atom. Thus, CX bond is not very strong and can be easily cleaved or removed. Therefore, both alkyl and benzyl halides are more reactive than vinyl and aryl halide. So, this is benzyl chloride C6H5Ca2Cl. So, here this benzyl group, here this CH2 group attached with this halogen atom. So here no vacant orbital, so here not possible CX double bond. Also here in alkyl halide this no vacant orbital, so here also not double bond possible. So in benzyl chloride and alkyl halide, in vinyl halide CH2CHX, the CX bond is stronger than the CX bond in alkyl halide. This is so because of a p orbital on halogen interact with p orbital on adjacent carbon atom. See above figure of vinyl chloride. The new delocalized orbital gives partial double bond character to the CX bond in vinyl halide. As a result, the halogen atom becomes firmly bound to carbon atom and cannot be replaced easily. In allyl halide, this is allyl halide, this type of interaction is not possible because the p orbital of the halogen atom is separated from the pi MO of the double bond by saturated sp3 hybridized carbon atom. As a result, the halogen atom in allyl halides can be easily replaced. Therefore, reaction of allyl halides are analogues to those of alkyl halides. It may be noted that primary allylic and primary benzylic halides show higher reactivity in nucleophilic substitution than other primary halides. This is because of greater stability of the allylic and benzylic carbocation intermediate formed by resonance. This is the resonance structure of benzylic carbocation. How benzylic carbon cation is formed? So resonance structure of benzylic carbocation. The intermediate carbocation formed during the nucleophilic substitution reaction is more stable in the case of allyl halides than in case of vinyl halides. In vinyl carbocation, there are no possibility of resonance and hence no resonance stabilization. Thus, the allyl halides and benzyl halides are highly reactive, and vinyl and aryl halide are very inert toward nucleophilic substitution. Thanks.